This video has been brought to you by Limitless Learning TT, a holistic learning center. In this session, we will answer 9 questions that are related to fractions and percentages. To obtain the full list of questions, please visit www.limitlesslearningtt.com, hover over the Outreach tab and select Free Material. For more information about our services, visit our website, limitlesslearningtt.com, or send an email to info@limitlesslearningtt.com, or give us a call at 868-610-1532. Okay, let's get started. So the first question asks us to find the answer to the following, which is 3 and 4 over 5 plus 2 2/3. So the method, there are 2 ways to do this. I'm going to use one method, and the second method, you'll see me use it in the next question. So what I'm going to do is add the whole numbers, because right now we have 2 mixed fractions or mixed numbers, which means you have an integer as well as a fraction. So I'm going to add the whole numbers. So that's going to be 3 plus 2, which will give me 5. Then now I'm going to focus on adding the fractions, which is 4/5 and 2/3. Now when adding fractions, if I have a different denominator, I have to find a common denominator, specifically the lowest common multiple. So I'm looking for the LCM of 5 and 3. And so that's actually going to be 15. So my denominator that's going to be common between both 4/5 and 2/3 is going to be something over 15. So I need to change 4 over 5 to something over 15. And I also need to change 2 over 3 to something over 15. Now if I'm looking at 4/5, I'm looking at the denominator. If I want to go from 5 to 15, I can multiply 5 by 3, and that's going to give me 15. So that means I'm also going to multiply my numerator by 3, and therefore 4/5 is the same thing as 12 over 15. And so now I'm going to do the same thing for my second fraction. 3 to go to 15 means I need to multiply 3 by 5 in order to get 15. So I'm also going to multiply my numerator by 5. 2 times 5 is going to give me 10. So 2/3 as a fraction is going to be the same thing as 10 over 15. So 2/3, same thing as 10 over 15. 4/5, the same thing as 12 over 15. Now that my 2 fractions are both have the same denominator, I can easily add them together. So now I am adding 4/5 plus 2/3, and that's the same thing as me adding 12 over 15 plus 10 over 15. And so 12 over 15 plus 10 over 15 is going to give me 22 over 15, or 1 and 7 over 15. So I added my whole numbers, which is here. Then I added my fractions, which is this. And so now I have to put them all together, and I get 5 plus 1 over 7 over 15, and that gives me 6 and 7 over 15. Now, this is one method of adding fractions. The next way that I'm going to show you is with a subtraction question. And so it's the same thing, different method. So let's look at that question. It asks us to find 5 and 1/2 minus 2 and 5 over 8. So what I'm going to do is I'm going to change these mixed numbers to improper fractions. So this is the second method. So with this second method, I'm going to change the first mixed number to an improper fraction and the second mixed number to an improper fraction. The way I do that is I multiply the whole number by the denominator and then add the numerator. So for the first mixed number. 5 times 2 will give me 10, plus 1 will give me 11. That's 11 over 2. That's so 11 over 2 is the same thing as 5 and 1/2. One is in the form of a mixed number, the other is in the form of an improper fraction. I'm going to do the same thing to my second mixed number, put back my subtraction sign. 2 times 8 is going to give me 16. 16 plus 5 is going to give me 21, so that is 21 over 8. So now I'm subtracting these two fractions. 11 over 2 minus 21 over 8. And again, the rules for adding and subtracting fractions, we have to have the same denominator or common denominator. So what I need to find, again, is going to be the LCM. And this time we're looking for the LCM of 2 and 8. And it so happens that the LCM of 2 and 8 is actually 8. So we already have one fraction that's in 8, so we're good to go. So all we need to do is change 11 over 2 to something over 8. And in order to get from 2 to 8, we would multiply 2 by 4. So 2 times 4 gives me 8. I multiply my numerator by 4. 11 by 4 is going to give me 44. So 11 over 2 as a fraction over 8 is going to be 44 over 8. So now I replace this. 44 over 8 minus 21 over 8. And that's going to be the same thing as 44 minus 21, which gives me 23 over 8. And so this is the answer as an improper fraction, but we can also change this improper fraction to a mixed number. That's the same thing as 2 and 7 over 8. Okay, so the first method, we added the whole numbers and then we added the fractions. With this one, we changed the mixed numbers into an improper fraction and then did subtraction. Next question. So my question says 2/3 of a number is 48, and I need to find 3/4 of the number. So what I want to write down is the information that I'm given. 2/3 of means to multiply. Some number, which I don't know, is going to give me 48. And I want to find out what is 3/4 of means to multiply that number, which I don't know. So the first thing I want to do is find a number. I know that 2/3 multiplied by this number is giving me 48. So if I want to find what the number is, I use my answer 48 and I do the opposite of the operation. My operation is multiplication. When we talk about opposite of multiplication, it's regarded as division. So if I did 2/3 multiplied by a number and I got 48, and I want to find out what the number is, I'm going to take my answer, which is 48. I'm going to do the opposite of my operation. My operation is multiplication. So the opposite of multiplication is regarded as division. And then I'm going to divide by 2/3. And that's going to give me back my number. Numbers and what's supposed to be in the box. When we divide a fraction, right, first thing, 48 as a fraction is the same thing as 48 over 1. When we divide by a fraction, we change the division sign to a multiplication sign, and then we flip the fraction. So the denominator becomes the numerator and the numerator becomes the denominator. That's something known as a reciprocal. And so now what we can do is we can simplify or do the cancellation process. 2 into 2 is 1. 48 divided by 2 is going to give me 24. So what I end up having is 24 multiplied by 3, which gives me 72. So therefore I'm saying 2/3 of 72 gives me 48. And you can always double check that to make sure that it's correct. Now my question is asking me to find 3/4 of that number, which I just found out is 32. So 3/4 of means to multiply 72 over 1, and this is a straight multiplication, so I can look at my numerators and denominators for factors that are in common between them. So 4 can go into 4 and 4 can go into 72, so 4 divided by 4 is 1, and 4 divided by 72 is going to give me 18. So therefore 3 times 18 gives me 54. So 3/4 of my number, which I didn't know and I found to be 72, gives me 54. That's my final answer. Next question. So Amy shared a bag of mangoes with her friends. She gave 1/5 to Jenny and 1/3 of the remainder to Paul. What fraction of the mangoes did Paul get? So again, I want to write down the information that I know. So Amy started off by giving 1/5 of her mangoes to Jenny. So Jenny got 1/5. Right? Then after that, she's going to give 1/3 of her remainder to Paul. But if she gave 1/5 to Jenny, what is her remainder? So if Amy started off with 1, which is a whole number, and then she gave away, subtraction, 1/5, that's going to be her remainder. So 1 minus 1/5. I need to change 1, which is a whole number, into something over 5, and that's going to be 5 over 5 minus 1 over 5, which is 4 over 5. So after she gives 1/5 to Jenny, her remainder is now 4/5. So Amy now has 4/5 remaining, and of that 4/5, she's going to give 1/3 of that 4/5 to Paul. So Paul, this is Paul over here, is going to get 1/3 of the remainder, which is 4/5. And now keyword of in this case means to multiply. So we're looking at finding 1/3 of, or 1/3 multiplied by 4/5. And so since there are nothing in common between my numerators and my denominators, I just multiply across the numerator, so 1 times 4 is 4, and multiply across the denominators, so 3 times 5 gives me 15. So Paul would get 4/15, which is the question. What is the question is asking you? What fraction of the mangoes did Paul get? He got 4/15. So now we're on number 5. There are 300 students in an auditorium. I'm writing down the information as I get it. 300 students. Of these, 210 are boys. What percentage of the students is girls? That's the first part. So I have 300 students. 210 are boys, which means that girls are going to be 300 minus 210, because your students can either be boys or girls. So if 210 are boys, then the amount of girls are going to be 300 minus 210, and so that leaves you with 90. Oops, sorry. So right here, I'm going to put down 90 girls. And so my question asks, what percentage of the students is girls? When we have of and is in a sentence, we do is over of. Okay, so the question asks, what percentage of students So my of represents students. Is girls. My is represents girls. So what I'm doing is putting girls over students, and then I want to find percentage. And when I want to find percentage, I always multiply by 100 over 1. So I'm going to take my number of girls, I'm going to put it over the number of students, and then I'm going to multiply by 100. So my number of girls is 90. I just found that out. My number of students is 300 in total. I'm going to multiply that by 100 over 1. So 100 divided by 100 is going to give me 1. 300 divided by 100 is going to give me 3. Then I can do, look at 90 and 3. 3 into 3 is 1. 90 divided by 3 is going to be 30. So now I'm left with 30. Oops. I'm left with 30%. Right, so again, in order to find the percentage, you multiply by 100 over 1. And then if in your question, in your sentence, you have the words is and of coming together in that same sentence, we do is divided by of. So in our case, is responded to girls and of responded to students. So our final answer for number 5 is 30%. Number 6 asks, which is greater, 3 over 4, 3/4, or 7 over 12? So we have 3 over 4, and we have 7 over 12, and we want to find out which is greater. Now, both of these fractions have different denominators, so we're not able to easily tell which one is greater. So what we need to do is get both of these fractions to have the same denominator, and then we can look at the numerator. Whichever one has the largest numerator, it means that that one is going to be greater. So we're looking at the denominators. We have 4 and 12. So first we have to find the LCM of 4 and 12. And it so happens that the LCM of 4 and 12 is 12. So we already have one fraction in terms of 12s, which is 7 over 12. So now what we need to do is change 3/4 to something over 12. In order to get from 4 to 12, we have to multiply by 3. So 4 times 3 gives me 12. I do the same thing for the numerator. 3 times 3 is going to give me 9. So therefore, 3/4 is the same thing as 9 over 12, and then 7/12 remains as it is. So now we definitely know which one is greater. 9 over 12 is greater. And 9 over 12 is the same thing as 3 over 4. So which is greater? In this case, it's 3/4. Number 7 says a piece of ribbon is 7 over 10 meters long. A piece measuring 2/5 of a meter is cut off. What is the length remaining? So we started off with 7 over 10 meters. Then we cut off 2/5 of a meter. And so cut off means that we're taking away, which means that our keyword indicates that we are subtracting. So this is going to be fractions and subtraction. So we're looking to do 7/10 minus 2 over 5. And again, we need to have the same denominator. So we look for the LCM of 5 and 10. And so the LCM of 5 and 10 is 10. So one fraction is already in terms of tenths. I just need to change 2 over 5 to something over 10. And if I multiply 5 by 2, that's going to give me 10. So I'm also going to multiply my numerator by 2. 2 by 2 gives me 4. And so now my question is 7 over 10 minus 4 over 10. And 7 minus 4 is going to give me 3 over 10. So my final answer is 3 over 10. Is the length of remaining. It's the length of ribbon remaining. Next question. In a spelling contest, Peter was given 40 words to spell. He spelled 32 words correctly. What fraction of the total number is spelled correctly? And then if Peter must spell 90% of the words correctly to qualify for a prize, how many words does he need to spell correctly to qualify? So this is a two-part question. I'm going to write down the information that I'm given. So Peter has a total number of 40 words to spell. Okay, he got 32 correct, so 32 correct. And so my first question wants to know what is the fraction, in its simplest terms, of words that were spelled correctly. So that's going to be 32 over 40. And the simplest terms means that I want to get this so that it can't go down any further, right? I want to reduce this fraction. So I'm looking for factors that 32 and 40 have in common, and one of them is 8. That works. So 32 divided by 8 is going to give me 4, and then 40 divided by 8 is going to give me 4/5. So 4/5 is the same thing as 32 over 40. So what I did is I divided both my numerator and my denominator by 8. So that's the first part of my question. Second part says that Peter has to spend 90% of the words to qualify for a prize. And again, keyword here, of by itself. Of means to multiply. 90, and the word percent means divided by 100. So 90% is the same thing as 90 divided by 100. And the total number of words we have as 40. 40 over 1. And that's going to give us how many he needs to qualify. So I am going to reduce or look at ways to reduce my numerators and denominators by looking at factors that are common to both. I'm looking at 40 and 100. I can divide both of them by 10. 40 divided by 10 is 4. 100 divided by 10 is 10. And then I'm looking at 90 and 10. They both have a factor of 10. So 10 divided by 10 is 1. 90 divided by 10 is 9. And so I'm left with 9 times 4, which gives me 36. So Peter needs to spell 36 words correctly to qualify for a prize. That's number 8. And finally, our last question, number 9, says Carl has $60. He spent 2/5 on snacks, 1/4 on arcade games, and he saved the remainder. So what fraction was saved, and then how much money was spent on snacks and arcade games? Again, this is a two-part question, and I'm going to write down all the information that I have. So Carl initially has $60. Then he spent on snacks 2/5, and on arcade games he spent 1/4, and then the remainder is savings, and we don't know what the remainder is. Okay, so we need to find the remainder. What we can do is add up snacks and games, and we can take that away from our whole, which is 1, right? Because we're talking in terms of fractions. When we're talking in terms of fractions, Carl started off with 1 whole. He gave 2/5 for snacks, 1/4 for games. So first we're going to add up snacks and games. So snacks and games is 2/5 plus 1/4. And again, we need to find the LCM of 5 and 4, which is 20. So now we're going to change both of them into something over 20. So 2/5 needs to go to something over, needs to go to something over 20, and then 1/4 also needs to go to something over 20. So if we multiply 4 by 5, it will give us 20. So we also multiply our numerator by 5. That gives us 5 over 20. And then on top here, if we need to go from 5 to 20, we multiply by 4. So we multiply our numerator by 4. 2 times 4 is 8. So essentially, when we're adding 2/5 plus 1/4, we're adding 8 over 20 plus 5 over 20. And that gives me 13 over 20. So Carl would have spent 13 over 20 on snacks and games. So the remainder, which was spent on savings, is going to be 1 minus 13 over 20. And so when we change 1 to something over 20, it's going to be 20 over 20 represents 1 minus 13 over 20, and that leaves us with 7 over 20. So the first part, which is what fraction was saved, would be 7 over 20, right? Because remember, when we add up everything, we're supposed to get 1, right? This is when we're talking about fractions. Now, the second part is asking us about money. It says how much money was spent on snacks and games. Now, we know what fraction was spent on snacks and games. 13 over 20 is a fraction that was spent on snacks and games. And so now we want to find out what is 13 over 20 in terms of money. The total amount of money that Carl has is $60. So we want to find out what is 13 over 20 of my $60 that I have. Of is my keyword, and again, of by itself means to multiply. So we're looking at 13 over 20. That's the fraction that represents snacks and games of the $60 that Carl has. And so my answer is going to be in dollars because, again, I'm looking to find out how much money was spent. So I can look at 20 and 60. The factor that can go into both of them, the highest one would be 20. So 20 divided by 20 is 1. And 20 divided by 60 gives me 3. And so 13 times 3 is going to give me 39. And again, we're talking about money spent, so I put in my $sign. So the amount of money that was spent on snacks and games would be $39. So that brings us to the end of this session. Again, this video has been brought to you by Limitless Learning TT, a holistic learning center. We answered 9 questions today that are related to fractions and percentages. And if you were looking for those list of questions, visit our website, limitlesslearningtt.com, hover over the tab that says Outreach, and then select Free Material. If you're looking for more information about our services, you can also visit our website, limitlesslearningtt.com. You can send us an email to info@limitlesslearningtt.com, or you can always give us a call at 868-610-1532. Thanks, guys, for tuning in.